All right, today we're going to start section 12.1. We're going to skip over the last section of chapter 11 just because of time with just people struggling to get through the content online. I have some flexibility in the outcomes and objective in this course anyway, so we're going to start section 12.1, which is sampling, frequency distribution, histograms, and stem and leaf plots. It's the beginning of statistical stuff and statistics, and we're going to start with a basic definition to start with, which we're going to use in all statistics. A population, okay, is a set containing all the people or objects whose properties are analyzed by the data collector, whoever that is. So we're going to be collecting data, and the population is the entire group of people that we are describing. Okay? Now, what's a sample? So that's a population. A sample is a subgroup of a population. Okay, it's a subgroup of the population. So a lot of times we can't actually, when we're trying to do statistics, we can't actually, like polling, for example, with voting, we can't actually poll everyone because not everybody will respond to a poll or answer a question. So what we do is we try to find a sample, and we try to pick a wise sample that's going to give an accurate prediction of the whole group. Okay, so we try to get people of different classes, different races, different ethnicities, different ages, different so on and so forth. We try to get a sample that represents the population well. Granted, it's not the entire population, but it's a large enough sample and a representative sample. Okay, we call it, I'm not going to write this out, but we call something a representative sample when it is a sample that fits the population and characterizes the population well. Okay, we can also have what's called a random sample. Okay, here's a random sample. A random sample is a sample obtained in such a way that every element in the population has an equal chance of being selected for the sample. So random samples are often used so that there's not a bias in who we're picking to be in our statistical study. You'll find in the media that oftentimes a lot of statistics are done with a lot of bias and used to deceive people or to promote a certain side of an argument, and there's not good representative or random sampling being done. Okay, let's take a look at this. City government wants to conduct a survey among the city's homeless to discover their opinions about a required residence in city shelters from midnight until 6 a.m. So city government wants to survey among the city's homeless to discover their opinions about required residence in city shelters. So describe the population. Well, it is all the city's homeless. That's the group that we are investigating. The city commissioner suggesting a sample by surveying all the homeless people at the city's largest shelter on a Sunday night. Does this seem like a good idea? Explain your answer. I would say no, because it isn't a random sample, and what about those not at shelters? I mean, it makes logical sense, right? That if people are not at a shelter, they might have an opinion about why they're not at a shelter. So it seems like you should be surveying people that are at shelters and people that are not at shelters, and people that are at smaller shelters as well. So now we're going to talk about a couple different types of distributions and charts, graphs, tables, things like that. And the first thing we're going to look at is something called a frequency distribution. This is where we list, we make a little chart, and you'll see how we do this. And the best way to show you how to do this is an example. Construct a frequency distribution for the data showing final course grades for students in a pre-calculus course listed alphabetically by student name in a grade book. Sorry for the noise in the background, by the way. My neighbor is doing his leaf blower. I don't know why when there's no leaves around. And also, just so you guys know, the Easter egg for this video is 1, 2, 3, 5, 7, 9. 1, 2, 3, 5, 7, 9. Okay, here's how we do this one. So we notice we make a chart, and the way we make the chart is we have two columns for the day showing the final course grades. So I make a final course grades column, and then I do a frequency. Frequency just means how many times does that grade appear. So there's 4 grades, A, B, C, D, and F. So how many A's are there? Let's just count them. 1, 2, 3, looks like 3 A's. So 3 A's. B's. 1, 2, 3, 4, 5. Looks like 5 B's. How many C's? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 of those. Okay. And then let's do D's. Looks like there's 1, 2 of those. You get the idea. This is pretty simple, right? And then F's is just 1. All right, so the total, how many total are there? Our N number is the total number in the list. We just add up those numbers. 3 plus 5 is 8, plus 9 is 17. Whoops. Plus 3 is 20. So N equals 20. That means there's 20 different people in the class. Okay, that's called a frequency distribution. Now I could do what's called a group frequency distribution. And that's a little bit different because now we're going to create like in our first column, we're going to create like a range of things. So like, for example, okay, let's try this one. So the difference here is now use the class to create a grouped frequency distribution. So now instead of representing every score, we're going to represent ranges of scores. So I could kind of do this by like A, B, C, D, and F. So I could go like score. So what I can do here is do ranges of scores. That's why it's called a group frequency tables, because we've got a group of scores in each row now. Okay? And that group of scores, we're going to look at things in that range. So basically, this is like F's, D's, and so on and so forth. So if I take a look here, 0 to 50, how many do I have? Well, it looks like I've got 1, 2, 3. Looks like just 3 in 0 through 50. Okay? And then how many do I have in 51 to 60? Well, looks like I've got 1 here, 2, 3, 3 as well. Get the idea? And then you could fill in the rest of the table. This is not rocket science, okay? So that's called a group frequency distribution table. And then you just Your n still is the total number of scores here. So if I do my n, looks like there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I've got 1, 2, 3, 4, 5. So this is 5, 10, 15, 20, 25. And then I've got 12 here, so 37. Okay, so that's my total number of n. So that's called a group frequency distribution table. And actually here I want to do one more example to introduce some terms as well. So we take a look at this frequency distribution here. A random sample of 30 male constants is selected. Each student is asked his height in the nearest inch. The heights are as follows. Construct a frequency distribution for the table. I'm going to do a group frequency distribution like we just did. So I'm going to go ahead. It looks like everybody, the lowest we get here is 60, right? So I'm going to go 60, just a simple one. So this is, whoops. This is height, and this is my frequency. Okay. And so I'm going to go 60 to 64, and then I'm going to go 65 to 69, and then I'm going to go 70 to 74. And then I'm going to go 75 to 80. Okay, so first of all, I want to introduce some terminology here. First of all, for each of these rows, okay, is called a class. Okay, we call these classes because they're ranges. We call them classes. All right, so those are classes. The first entry in each class is called the lower class limits. Okay, and then the second item is the upper limit for each class. These are called the upper class limits. Okay, and then we find the width of each class. The class width is found by taking one lower class limit and subtracting it from the last lower class limit. So you subtract, and notice it's consistent, 75 minus 70 and 65 minus 60. So that is some terminology of lower class limits. There's 1, 2, 3, 4 lower class limits. There are 1, 2, 3, 4 upper class limits, and the class width is 65 minus 60, or I could have done 70 minus 65. There's a lot of different ways I could do this. So I'm going to erase all that, get through that, okay? So now let's do the distribution. Now to do my frequency, you already know how to do that. 60 to 64. It doesn't look like I have any in there. No, I do not. So that'd be 0. Okay, and then you can go on and fill the rest of those in. I just wanted to introduce the terminology there. Okay, now we're going to go to stem and leaf plots. Okay, we're going to do a problem we've already done, but instead of constructing a grouped frequency distribution, we're going to do a stem and leaf. And we're going to use this data. Okay, so a stem and leaf means that we create a stem category. So we're going to have an overall table. And we have a stem column and a leaf column. This is really helpful to visualize what's happening here, okay? So the stem column, what we do is we put the first digit, all the possible first digits. What looks like the only first digits we have in this, looks like 4 is the lowest tens digit we have. Okay, so we're going to go 4, 5, 6, 7, 8, and 9. And then we just list all the leaves. That would be all the ones digits that we have that go with that 4. So it looks like there's just a 41, and that's all we have. Look at the 50s now. Well, we got a 58, another 58, a 57, a 50, and a 52, and I may be missing one. Sometimes I miss one. So let's do those in order. We've got a 50, so a 0 ones place. We've got a 2. We've got a 7, and we've got 2 8s. So that means my scores, the way I would read this if I was reading back, is I've got a 41 is one of my scores. I've got 1, 2, 3, 4, 5 in the 50s, scores in the 50s. I got a 50, a 50, a 52, a 57, a 58, and a 58. So basically the stem is the tens place, and we could do all kinds of different stems for all these different problems. Then of course I can go to the 60s. Let's look at the 60s. I got a 68, a 68, a 62, and a 69. So I got a 2, 8, and 9 for my 60s. And then my 70s, let's go through that one. Looks like I got a lot of 70s. I got a 73, a 75, a 79, 79, 77, 75, 75, 73, 73, 76, 77, 71, 77, 71. So how many 70s do I have? None. 71s, it looks like I have 1, 2 of those. So I do a 1 and a 1. 72s, no 72s. 73s, I've got 1, 2, 3 of those. '74s, none. '75s, 1, 2, 3 of those. 75. '76s, 1 of those. '77s, 1, 2, 3 of those. I got no 78s, and I got 1, 2 79s. So that'd be a stem and leaf plot. I could do the 8s and 9s as well. So that's how we build a stem and leaf plot. Okay, now we're going to look at histograms and frequency polygons, which are a visual display of these different ways of looking at things. They're both very similar. We're going to look at this data. This data is stress ratings that students gave leading into a finals week at a college. So they were able to rate their stress on a scale from 0 to 10. And this was the frequency distribution of how many people reported having, for example, the number of people that recorded having a stress level of 7 was 31 people, okay? So we're going to create a diagram for this. And we'll first do a histogram. And the histogram is what you would more commonly know as a bar graph, okay? And what we do is it's really simple. On this axis, we have the stress rating. And on this, we have the frequency, okay? And it looks like we go up to a maximum of 31. So I'm going to go with 1, 2, 3, 4, 5, 6, where this is 5, 10, 15, 20, 25, and 30 on the frequency there. And the stress ratings, we're just going to go with 1, so I'm going to first create a bar. So who had a stress rating of 0? Call this 1, 0. Well, 2 people had a stress rating of 0, so I kind of make a bar that's about too high. Who had a stress rating of 1? Looks like 1, so they'll call this little area 1. Looks like 1 person, so I'll create a little bar that's 1 high. 2, 3, a 3 was about right there, let's say. Not quite 5. And then we go to 3, the stress rating. And we're up to 12 now. It's a little above 10 here. And a lot of times what will happen in a frequency distribution is you'll actually put the numbers up above it. So this would be a 2. This would be a 1. This is a 3. This is a 12, just if it's not clear how high it is. And then for 4, we're at 16. Just a little above the 15. Okay, so this is called and I could go on and on and on here. You get the idea on how to build a histogram. So that is a histogram or a bar graph, okay? Now the frequency polygon is identical to that in a lot of ways, okay? The difference is that with that, again, I do my stress rating down here, and my frequency up here. So this is, again, each of these is 5, we'll say. Let's fix that. Let's make that a little bigger. Okay, so this is 5, 10, 15, 20, 25, 30. All right, so now 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So at 0, we're at, now what I do differently is I put a dot, I plot a point. So at 0 stress rating, we have a frequency of 2. At 1 stress rating, we have a frequency of 1. At 2 stress rating, we have a frequency of 3. At 4 stress rating, we have at 3, sorry, so this is 3. At 3 stress rating, we have a frequency of 12. At 4, we have a frequency of 16. At 5, we have a frequency of 18. At 6, we have a frequency of 13. Masturbating here. At 7, we have a frequency of 31. Oh boy. That's way up here. Then for the frequency polygon, we just literally connect these with straight lines. Ignore the fact that these aren't perfectly straight. I don't have a straight edge on my iPad, obviously. And then we could go on and on and on. So the only difference is between these two graphs is in this one I draw bars, and in this one I plot points and connect the dots. Okay, so that's the difference between a frequency polygon and a histogram. So we've done frequency distributions, we've done grouped frequency distributions, we did stem and leaf, we did histogram and a frequency polygon. That's all you need for this section, and that should get you going for today.